In this video, you will learn how to optimize your dynamic factory to speed up your simulation. I'm Cesar Barreto, a senior engineer at Altair. I'll start with a brief explanation of EDEM factory types, and then I'll show you how you can improve your factory performance. First, static factory. This example shows a mixer drum with 3 different types of tablets. I'm using 3 static factories to generate the different materials in the simulation. Also, full details of particles generating parameters, including how to reactivate a static factory, are explained in the EDEM Learning, Lesson 6, and I will leave the link in the comments below. Next, once your model is set in the creator, move to the EDEM Simulator and start processing. Here, we can see the material is generated at different time steps, and static factories can also be used to generate bill of materials. Another tool that we can use to generate granular material is volume packing. This tool is designed to quickly fill a geometry with particles, and it can be used for agriculture, off-road vehicles, and heavy equipment sectors. For this example, I set a material model, including particle shape and size distribution, using EDEM Material Library. I imported a bucket geometry and a factory geometry that will generate the material. Right-click on the geometry and add volume packing. You have controls over several settings to generate the material bed. First, select the materials that will fill the imported cut volume. Set the start time and appropriate solid fraction. For further information on configuration settings, check the EDEM documentation, and we also have a complete e-learning lesson on this topic. I'll leave the links in the comments. And once you have completed the setup of your simulation, save your file and switch to the EDEM simulator. Start processing to generate the bill of material. Here in the analysis, we can hide some of the geometries, and we can see the material created using the factory geometry we imported. Next, let's check dynamic factories. For this simulation, the granular materials, geometries, and physics have been defined. There are 2 types of geometry that can be used as a factory. You can use either a closed physical geometry, for example, a box or a cylinder, or any virtual geometry which won't interact with particles in the simulation. We have the factory parameter settings, which define how your material is created. Next, if we run the simulation again, we can observe the material being generated with a constant flow, and that's an indication that the factory is creating the material as expected, without any issues. However, we may have some situations where the material created is struggling to get into the simulation space. And for those cases, let's see how you can optimize your factory. Here, we have a factory geometry with the following dimensions. We have set the total number of particles and generation rate values for this case. If we run the simulation again, we can see the particles are being generated really slowly. And the key message here is that during material creation, no particle will be created that touches either another particle or a geometry surface. This is a key point when particles are generated. And that could be due to different factors. First, check the source report. Right-click on the toolbar and check regenerated and failed particle numbers. This large number is an indication that EDEM is struggling to find a space for particles to be created, and we have to improve the factory settings to speed up the simulation runtime. Stop the simulation, move back to the creator, then select time 0 to apply the changes at the start of the simulation and press save. First, increase the factory geometry to ensure we have enough space for the particle creation rate that we have set. Next, go to the factory settings and reduce the generation rate value. Next, we can add an initial velocity for the particles to leave the geometry quicker. Finally, we can save the simulation at time 0 and start processing again. By improving the factory settings, we can observe the material is flowing much better. Also, in the solve report, we can see that the particles regenerated have decreased, and we don't have any failed particles. And the last thing we can do is to add a movement. In this case, we have a polygon, a plate, and we're going to do a translation kinematic to move the plate outwards. What we're creating here is more space for the particles to be created. Here we have almost the same simulation. The only difference is that we added a translation kinematic to the factory geometry, which provide more space for the particles being created. We can also observe that the particles regenerated is lower when we're using a translation kinematic. As a summary, remember to check your factory settings, and also depending on your simulation, you may use either dynamic factory, static factory, or volume packing. Also, if you want further information about factory, please check the EDEM Learning Lesson 6.